Hello and welcome back. In this video we'll continue to look at transformations of functions and graphs. So next up we're going to look at what happens when we multiply by numbers rather than adding. So here we've got our initial function is going to be the absolute value of x, and we'll see what happens. Oh, this should be 2 times the absolute value of x. What happens if we multiply by a number that's bigger than 1, or what happens when we multiply by a number that's smaller than 1, if say 1/3 x. Well, our absolute value function looks like the identity function on the right hand side, just this nice straight line, and on the other side it's reflected. So when we multiply by 2, on the other hand, if we plug in 0, 2 times the absolute value of 0 is 0. 2 times the absolute value of 1 is 2. 2 times the absolute value of 2 is going to be 4, which will be way up here. And we see a similar thing on the other side. And essentially, if I could draw very well, essentially what happened is this picture has been stretched vertically. When we look at the height of a function at any one point, we are multiplying it by 2, so we're doubling it, meaning that we're taking it further and further away from the x-axis. So this is going to be, it will fix anything at 0, because anything times 0 is still 0, but anything else is going to be stretched away from the x-axis. If we had points down below, they'd again be stretched away from the vertical axis. We're grabbing the top of the function, the bottom of the function, and pulling it so that it gets stretched. However, if we multiply by 1/3, now each of the heights of our original function is going to be reduced by 1/3. So at 0, 1/3 times the absolute value of 0 is still 0. 1/3 times the absolute value of 1 is 1/3, and 1/3 times the absolute value of 2 is going to be 2/3. And a similar thing will happen on the other side. So now what we've done is we've sort of shrunk our graph. It's as if we're pushing down on it from the top and pushing up on it from the bottom, and we've pushed the graph together. So what the original graph looked like has now sort of shrunk, and now everything doesn't get quite as far away from the x-axis. So we're shrinking everything so that it doesn't get as far away. And this is in general what happens. So when you multiply a graph by c, let me move this over so you can read this. When you multiply a graph by c, if we're multiplying by a number bigger than 1, we're stretching it. We're pulling it away from the x-axis. If we multiply our graph by a number that's between 0 and 1, we're shrinking it. All of the heights are going to get closer and closer to 0. So you can see that 1/3, yes, we're pushing everything closer to the x-axis, but with 2, we're pulling everything away from the x-axis. So this is vertically stretching and shrinking graphs, but this is multiplying f of x, the function height, times c. We could also multiply x itself by c. And when we look at this, if we take f of x and we multiply the x by the c, this is going to affect the x coordinates. So we're going to shrink and stretch the graph horizontally as opposed to vertically. And while this may seem backwards at first, we'll look at this in a second. If we multiply by a number that's bigger than 1, if we multiply x by a number that's bigger than 1, we're going to shrink horizontally. And if we multiply by a number that's less than 1, but still positive, we're going to stretch horizontally. And this seems a little bit backwards to what we saw before. If we multiply the height by a number bigger than 1, we stretch it, and by a number smaller than 1, we shrink it. Whereas in this case, the shrinking and stretching will be flipped. So let's look at an example. So here I have a function. I've just plotted a few points. So starting from -3 to 0, we're increasing. So this will be up to 3. Over here at 3, we come back down to 0. At 4, we're down at -1. And then we climb back up for 5. So if we multiply the x coordinate by 2, what will end up happening? So if I plug in, let's say 1 into my into this here, this is going to be the same thing as f of 2. So at 1, we're going to get the same thing as f of 2, and at 2, the height was 1. At 0, if I plug in 0 into here, I'll just get 0 again. If I plug in -1, I'm going to get the function height at -2. And we can begin to see that our function has shrunk. We have compressed everything. So whereas before our function hits 0 at 3, now our function is going to hit 0 at 1/2 of 3, at 1.5. It hits -1 at 4, so instead now it's going to hit -1 at 2, and then it will climb back up. So we have compressed this horizontally because we've multiplied all of the x coordinates by 2. If we were to multiply by 1/2 on the other hand, now we're going to stretch everything. So whereas on this left-hand side, -3 is where we're at 0. Now, since we're multiplying by half, we're going to be at 0 at 1, 2, 3, 4, 5, -6. So we're stretching this by a factor of 2. And we'll still climb up to 3. And then we'll climb back down to 0, but instead of hitting 0 at 3, we're going to hit 0 at 6. 1, 2, 3, 4, 5, 6. And then we'll shrink down 1 before climbing back up 1. So again, when you multiply by a number that's between 0 and 1, so it's still positive, but between 0 and 1, we're going to stretch our function, as opposed to multiplying by a big number, which means that we're going to compress our function. Essentially, we have to compensate for those numbers by stretching or shrinking. So let's review everything that we've seen. We can lift up or raise a function by adding c to the height, or we can lower a function by subtracting c from the height of a function. We can shift to the left or to the right. We shift to the left by adding c to x, or we shift to the right by subtracting c from x. If we want to reflect about the x-axis, so up becomes down, we need all of our values to become the opposite sign. So all the positive values become negative, all the negative values become positive, so we multiply by -1. If we want to reflect about the y-axis, so we're shifting left and right, swapping left and right, this means that the positive x values need to become negative x values, and negative x values need to become positive x values. So we multiply x by -1. And then the last ones that we've seen are going to be stretching and shrinking. So if we want to stretch the height vertically, we're going to multiply by a number that's bigger than 1. We're going to pull everything away from the x-axis. If we want to shrink everything vertically, we're going to multiply by a small number, a number that's close to 0, and that's going to compress everything down toward the x-axis. If we want to shrink everything horizontally, as in make everything get closer and closer to the y-axis, we're going to multiply x by c, where c is going to be a number bigger than 1. But if we want to stretch everything out, if we want to pull it to the left and right, so we want to stretch it horizontally, we're going to, again, multiply x by c, but now we're going to multiply by a small number. So keeping all this in mind, there is an order that you'd want to perform transformations in. When we look at an example, which we will in a second, we want to take into account all the horizontal shifting first, then all of the stretching and shrinking. Then we'll see if we've reflected about the x-axis or y-axis to see if we've flipped anything over. And then at the very last step, we will see if we shift up or down. So let's go through this. I have some notes here that I'll go through in a second. So let's take this graph. We've got g of x is going to be 2 times x plus 3 squared minus 1. So when we look at this, what we see is that this is going to look like an x squared. But we can see that we've shifted horizontally by adding something to x directly. We can see that we've stretched our function by multiplying by some number, and we've also shifted vertically by subtracting a number at the end. So as I go through this, I'm going to take each one of these into account first. So if I were to graph f of x first, if I were to graph x squared first, I need to take into account all the horizontal shifting first. Well, horizontal shifting is done by adding something directly to x. So instead of having x squared, we're going to have x plus 3 squared. So now we've shifted x. So we've shifted to the left and to the right, which is horizontal. Next, we need to look at any circumstances where you have stretching or shrinking. And here, we're going to stretch vertically by a factor of 2. We're going to take all of these, all of the heights, and we're going to stretch them up by a factor of 2. And then reflecting, we reflect if we make x or if we make x negative, or if we make the whole thing negative. But we don't have a negative sign in front of any x or multiplying anything that's multiplying x. So there is no reflecting in this example. The last thing is this vertical shift at the end. So we're just going to take whatever our function happens to be, and we're going to shift it, in this case, down by 1, since we're subtracting 1. So let's graph these. So if we start with our function, so let's graph x squared first. X squared is a nice parabola. And it'll look something like this. Hopefully you can draw better than I can. And then the next, so the first transformation is our horizontal shift. And when we shift this horizontally, when we add 3, that means that we're shifting it to the left. So we've shifted this to the left, and now we want to do the same thing for this third one, which we're going to multiply everything by 2, meaning all of the heights of this function are going to be increased quite rapidly. So instead of reaching a height of 1 at negative 2, we're going to reach a height of 2 at negative 2. And then by negative 1, where we would hit 4, we're going to be way up at 8. So our U is now becoming a sharper and sharper U. And I apologize, this is meant to look like this is being shifted up from this last one. My drawing skills freehand aren't the greatest. And then the very last thing that we'll do is we notice, oh, when to go from this function to this function, they're the same except I've just subtracted 1. So we're going to take that whole thing and we're going to shift it down. So whereas our initial parabola was at 3 and would hit the x-axis right here, what we're going to do instead is shift that down. Oops. By 1. So here is now going to be the bottom of the parabola, and it's still quite steep because we multiplied everything by 2. So this is going to be the final shape of our parabola after we have shifted it to the left, stretched it, and shifted